All right, let's dive right into a really fascinating, kind of counterintuitive puzzle from the front lines of AI. You'd think, logically, that giving an AI a consistent self, or an identity, would make it more stable, right? But what if I told you the exact opposite is sometimes true? What if giving an AI an identity is the very thing that can make it completely and utterly fail?
So this is the core mystery we're unpacking today. You have developers trying to make a model more reliable, giving it this persistent persona, and yeah, sometimes it works like a charm, but other times the whole system just collapses. Why? That's what we're going to figure out.
And you can see the problem laid out so clearly here. We've got two models. We do the exact same thing to both. We give them an identity. Model A, rock solid, becomes super stable. Model B goes completely off the rails. It's the same action, but with these wildly different, catastrophic outcomes. That's the paradox, and we need to get to the bottom of it. Okay, so here's our game plan for cracking this thing open. We'll start with the paradox itself. Then we're going to do a big mental shift from thinking about psychology to thinking about geometry. After that, we'll use a simple analogy, a tightrope walker, to understand the basic rule, the two very different sides of identity, and how stability can actually become fragile. And by the end, it'll all click into place with a big geometric takeaway. All right, let's kick things off with the paradox itself. And just to be clear, this isn't some abstract thought experiment. This is a real, practical problem that engineers are grappling with right now as they try to build more dependable AI. You know, the idea behind this makes a ton of sense. You've got this incredibly powerful AI model, but sometimes its behavior can just drift. It becomes inconsistent. So the idea is to give it a fixed identity, a set of rules, a persona, whatever, to act as an anchor, to keep it on track. It's supposed to be a safety rail. But here is the big plot twist, and this comes straight from the paper we're looking at today. If we want to understand this paradox, we have to stop thinking about AI identity in terms of personality. We have to stop thinking about consciousness. The secret isn't in psychology, it's in geometry. And this quote from the author, Skylar Fiction, just nails it. They're saying identity isn't about what an AI thinks or its meaning. It's a mathematical force, a geometric intervention that literally changes the shape of all the possible things the AI can do. So think of it less like giving the AI a personality and more like physically changing the landscape it has to navigate. Okay, admissible state space. That's a bit of a mouthful, right? So to make this all really click, we're going to use a simple analogy for the rest of this explainer. Just imagine our AI is a tightrope walker. The goal is simple. Walk along the rope, don't fall off. That straight path on the rope, that's the AI's stable, desired behavior.
So what keeps any tightrope walker from falling? Well, it turns out there's this really simple, almost universal rule that basically decides everything. And it all boils down to two key ideas.
Okay, first up, time to failure. We'll call it tau fail. It's exactly what it sounds like. Once the walker really starts to lose their balance, how long do they have before it's all over? Is it a slow, graceful tilt they can maybe recover from? Or is it a sudden, catastrophic plunge?
And on the flip side, you've got recovery time, or tau rec. So when that wobble starts, how fast can the walker correct it? How quickly can they snap back to a stable, balanced position? Are they nimble and quick, or are they slow and clumsy?
And here's where it all comes together. This is the magic formula. For our tightrope walker to stay on that rope, to persist, their recovery time has to be shorter than their failure time. You have to be able to fix the problem faster than the problem takes you down. Simple as that. As long as this rule holds, you're safe. The moment that flips, game over. So how does this all connect back to AI identity? Well, in our analogy, adding an identity is just like installing guide rails along the side of that tightrope. And at first, that sounds great. What could go wrong? Well, it turns out these rails have two very different competing effects. So on the one hand, the good news, the rails are great for suppressing those small wobbles. The walker can lean on them, stop little stumbles from turning into big ones. This is the stability everyone wants. But, and this is a huge but, the rails also narrow your path. If the walker loses their balance so badly they need to take a big, dramatic step to the side to recover, they can't. The rail is in the way. They've actually made a full recovery way, way harder. And this is the moment it all makes sense. This is how we solve the paradox of why those guide rails, our AI identity, can be a huge help for one system and an absolute disaster for another. See, the key isn't the guide rails themselves. It's the tightrope walker. How good were they before you installed the rails? The paper calls this the system's
intrinsic curvature, which is just a fancy geometric way of asking, how stable is the system on its own? Are we dealing with a shaky novice or a seasoned pro? And this chart just lays it out perfectly. For a system that's naturally unstable, our shaky walker, the guide rails are a lifesaver. They provide much-needed support. But for a system that's already really stable, our expert walker, the rails actually do more harm than good. The expert doesn't need help with small wobbles, and the rails just get in the way of their big expert recovery moves, making them less stable. Incredible, right?
So the paper breaks it down into 3 scenarios, or regimes. First is the stabilizing regime. If your system is naturally wobbly and unstable, adding an identity helps. It creates order. But then there's the destabilizing regime. If your system is already super stable and efficient, adding that same identity makes it brittle. It can't handle shocks anymore. And of course, there's a neutral regime where the identity just doesn't really matter for the task at hand.
So what's the big takeaway here? What's the one thing you should walk away with? It's that we have to stop thinking about AI identity as a personality. It's not about psychology, it's about physics. Now, it's super important to be clear about what this theory isn't saying. It's not claiming that identity makes an AI smarter, or that it creates consciousness, or anything like that. And it is definitely not saying that identity is always good or always bad. It's much more specific and honestly a lot more useful. This is the sentence to remember. The crucial point is that identity is a curvature operator. It's a mathematical tool that literally bends and reshapes the space of an AI's possible behaviors. And whether that tool helps or totally backfires all comes down to its geometric compatibility with the system you're applying it to.
Which leaves us with a really big question to chew on. If what we call an AI's self is actually just a function of its underlying geometry, what does that mean for the future? Should we be focusing our energy on building artificial personalities? Or should we be designing predictable geometries? This paper suggests the answer might be very different from what we've always thought.